Good good afternoon to the lecture 26 of fluid mechanics. Good afternoon to the lecture 26 of fluid mechanics. So we are in the lecture 26 of Unit 2. So we are in the concept of pipe bend problems and types of motions in the dynamics, viscosity of fluid flow. Right? Okay. So we have maximum, we have completed all the topics here. So and we are in the pipe bend problems and also the types of motion in this thing. The forces of pipe bends problems and the types of motion we will discuss in this class. Right? Now see so already in the last classes we have derived about the pipe bend formulas. Now we'll see the various problems associated in this slide. So here the pipe of 300 mm diameter, a pipe of 300 mm diameter converting 0.03 meter cube of water has a right angled bend in a horizontal plane. Find the resultant force exerted on the bend if the pressure at inlet and outlet bend are 24.525 Newton per centimeter square and 23.544 Newton per centimeter square. So ఇక్కడ మనకి ఇన్లెట్ దగ్గర ఎంత ఇచ్చాడు, it is given as 24, outlet దగ్గర it is given as 23. Now what is the thing you have to find the resultant force కావాలన్నాడు. Now draw the figure, or it is a draw the figure is drawn. So we are having the initial velocities p1, a1 and v1, v2, p2 and a2. So this is cross section at 1 1, cross section at second place. This is the x-axis direction, this is the y-axis direction. Now write the given data. What is the given data? What is the pipe diameter? Uniform diameter is d is equals to 300 mm, that is equal to 0.3 meter. Then what is the area? After knowing the diameter, find the area. Area is same. Why? Because the diameter is same. So area is equals to a1 is equals to a2, that is equal to pi d square by 4. Then what is the pi by 4? What is the d? 0.3 square, that is equals to this is the value. Then what is the discharge? Q is equals to, already given, that is 0.30 meter cube per second. So you got the values, the diameter, the area and the discharge. Then what is the velocity according to the momentum? V is equals to v1 is equals to v2, that is equals to q by a. Therefore v is equals to, q is given, a is given, the value is v1 or v2 is equals to 4.244 meters per second. Right? Next. Now the angle of bend. So what is the angle of bend here? The angle of bend is 90 degrees. The angle of bend is 90 degrees. From this figure, the angle of bend is 90 degrees. Then what is the pressure P at inlet? The pressure P at inlet is 24.525 conversion into Newton per meter square, that is 24.5250 Newton per meter square. Next, what is P2 here? The P2 is 23.544 into 10 to the power of 4, that is equals to 23.5440 Newton meter square. Then now the force acting in the x direction. See here, the force acting in the x direction. So what is the forces acting in x direction here? F of x is equals to rho into q, changes in the velocity, plus p1a1 plus p2a2. So this is the formula for the pipe bend, already మనం derive చేసాము. Now where rho is equals to 1000, we know v1x or v1 is equal to 4.244, already we have derived. v2 is equals to 0. Now applying this one, p1 into a1 into x, p1 into 1000, pressure p1 is equals to 245250 into area, that is equals to, we are getting some value. So p2 a2 in the x direction ఏంటి 0. అంతే కదా, x డైరెక్షన్ లో మాత్రమే మనం చూస్తున్నాం కాబట్టి అదర్ థింగ్స్ 2 సెక్షన్ లో ఉన్నవి 0. సో సెక్షన్ 2 కాబట్టి 0, సెక్షన్ 2 కాబట్టి 0. Therefore f of x is equals to 1000 into, write this formula, 1000 into the discharge 0.30 into bracket 4.244 minus 0 plus this one into plus 0. So what is the value you are getting? We are getting 18.607.5 Newton, that is f of x. Now the force acting along the y-axis. So y-axis for this one, same formula after applying this one, rho into Q, V1y minus V2y plus P1 into A1 whole to the power of y plus P2A2 into y. Now ఇక్కడ ఏంటి y డైరెక్షన్ లో ఉన్నది మాత్రం తీసుకొని x డైరెక్షన్ లో మనం 0 పెట్టుకుంటాం. Therefore V1 లో సెక్షన్ 11 లో 0, V2 is equal to value. Therefore P1 A1 y is equals to 0. సెక్షన్ 2 కాబట్టి దీన్ని మనము అప్లై చేసుకుంటాం. P2A2 y is equals to minus P2A2 that is equals to 23540 into 0.07, that is the value. Therefore f of y is equals to 1000 into 0.03, 0.30 that is discharge whole to the bracket, 0 minus 4.244 to the bracket plus 0 minus this one. So finally f of y is equals to minus 17.141 Newton. Then what is the resultant force? The resultant force Fr. Resultant force. So ఈ pipe bends లో మనము గుర్తుపెట్టుకోవాల్సిన ఓన్లీ 3 ఫార్ములాస్. వన్ ఈస్ x axis లో ఫార్ములా ఏంటి, సేమ్ థింగ్ ఫర్ y axis, ఓన్లీ xy చేంజ్ అవుతుంది. రిజల్టెంట్ ఫోర్స్ దిస్ ఇస్ ద ఫార్ములా. f of fr is equals to root of f of x square plus f of y square. That is equals to, apply, substitute these values here, you are getting this formula, this value. Now what is the angle you have to find? Tan theta is equals to fy by fx, that is equals to 0.9627. Therefore theta is equals to 43 degrees 54 minutes. That is a value you are getting for this pipe bend problem. Okay, yes. Next problem. Yes. So in this problem, we are seeing a 250 liters of oil flowing in a pipe having a diameter of 300 mm. So the 250 liters of water flowing in a pipe having the diameter of 300 mm. If the pipe is having a bend, pipe bend ఎంత ఉంది? It is a 135 degrees lo we are having a pipe bend. At 135 degrees we are having a pipe bend. Yes. Hello, check. So at 135, check. Okay, hello, audible? Okay. So 135 degrees, that is a change from this. Final direction is 135 degrees. Find the magnitude. Find the magnitude and the direction of the resultant force on the bend. Take the values. Take the pressure of the water flowing is 39.24 Newton per centimeter square. Now what is the given data? Pressure is given. Okay, so convert into Newton per meter square. Next, what is the discharge? The discharge of water is 250 liters per second. That is equals to, convert into meter per second, that is 0.25 meters per second. Then what is the diameter of the bend and inlet and outlet? Same kabatti d1 is equals to d2 is equals to 300 mm, that is equals to 0.3 meters. Now what is the area? When you got the diameter, area 1 or area is equals to, area 1 is equals to area 2, that is equals to pi d square by 4, that is equals to 0.07068 meter square. That is the area we got. Now what is the angle it has given? The angle is given as 135 degrees and it's shared. So we have to draw a pipe with the same diameter, 300 mm diameter. The velocity v1, the pressure p1, the velocity v2, the pressure p2. Okay, when the pressure is going inlet, so it is going in this direction and taking in this direction. So whenever it's taking a bend with an angle of 135 degrees centigrade, so calculate at the A and B. So if you see at A, so it is making 45 degrees, right? It is making 45 degrees. So the pressure is towards down. So velocity of water section 1 and section 2, V is equals to V1 is equals to V2, that is equal to Q by area. So substituting these values, you are getting 3.537 from the force along the x-axis. The force along the x-axis. Now see, same f of x is equals to rho into V, rho into discharge into V1x minus, ఇదే ఫార్ములా అప్లై చేయండి. V1x minus V2x plus P1x A1 plus P2x A2. Now where V1x is initial velocity, that is 3.537, already మనం తెచ్చుకున్నాం ఇక్కడ. V2 మనకి ఇక్కడ సెక్షన్ 11 కాబట్టి ఇక్కడ మనకి other value in next direction, velocity, final velocity in the direction of x, V is equals to minus V2 cos 45 degrees. So here minus V2 cos 45 degrees, minus V2 cos 45 degrees. So this one. So it is making at an angle, this one. So making x-axis and y-axis, making with an angle 45. So this one is a V2, velocity is V2, it is going upwards. So ఈ velocity మనం velocity pressure construct చేసుకొని, so velocity towards upward direction. So this opposite side we are getting V2 sin theta, adjacent side we are getting V2 cos theta. Therefore applying here in the direction of x, x is equals to minus V2 cos 45, that is equals to, substituting this one, we are getting the value. Next, pressure at P1, which put it this one, pressure at P1, section 1 in x direction. So already we know that pressure at P1 is equals to 39.24. Conversion is 39.24 and 24 of Newton per meter square. Now P2 at pressure 1, P2 at section 2 in x direction is equals to, so here P2 at pressure 1 is in x direction is P2 cos 45, that is P2 cos 45. So P2 cos 45 degrees, substituting here we are getting the value. Now what is f of x? Substituting all values, substituting 1000 into discharge is 2.25 into V of 1x is equals to this one minus V of 2x plus P1x into A1, P1x into A1, P1x into A1, that is a value you are getting. So substituting all this one, we are getting the value. So thereby in the x direction, the value is 48,855.4 Newton. Now the same apply for the y-axis. F of y is equals to, this is the formula, right? Now V1 is equals to V1y is equal to initial velocity in y direction. Y direction it is 0. V2y is equals to minus V2 sin 45. So applying the same for the all the problems, pipe bend problems today. Now minus V2 sin 45. After substituting this one, you are getting the value. Therefore P1 A1 into y, pressure force at section in y direction is 0. So pressure section at in y direction at 2 is minus P2 A2 sin 45. So ముందు మనకి P1 A1 sin cos 45 అయితే ఇక్కడ P2 A2 sin 45. Therefore substituting P2 value and A2 value and sin 45, we are getting f of y is equals to 1000 into 0.25. So ఈ values దీనిలో substitute చేస్తే, so finally you are getting minus 20 to 36.3 Newton, that is f of y. The negative sign indicates what? F of x is acting in a downward direction. Here the f of x is not 90 degrees. Here the f of x is, here the f of y is coming downward direction. That's why it is minus direction. Therefore, what is the resultant force? The resultant force Fr is equals to root of fx square plus fy square. Now that implies substitute these values, simplify, substitute these values here, you are getting the resultant value 52,880.6 newtons. Now we have to find the theta, right? Therefore the theta is equals to f of y by f of x, f of y by f of x. Therefore f of y values ఇక్కడ substitute చేయండి, x value substitute చేయండి, we are getting the theta is equals to 22 degrees 30 minutes. సో ఏ ప్రాబ్లం చేసిన పైప్ బెండ్ ప్రాబ్లమ్స్ లో ఫస్ట్ మనం f of x వాల్యూస్ తీసుకోవాలి, f of y వాల్యూస్ తీసుకోవాలి, రిజల్టెంట్ ఫోర్సెస్ is equal, fr is equals to root of fx square plus fy square. తర్వాత tan theta వేసి theta value కనుక్కోవాలి, right? Yes. The next one, a 300 diameter pipe carries water under a head of 20 meters. So what is the diameter of the pipe? 300 meters. Carries under a head, what is the head height? 20 meters with a velocity of 3.5 meters square per second. 3.5 meters. If the axis of the pipe turns through 45 degrees, find the magnitude and the direction of resultant force of the bend. Now they're asking to find out the bend. Okay, the same thing applying here also. Now, what's the given data? The given data is the diameter of the pipe is constant, that is 300 meters, that is 0.30 meter. And what is the area? Area is also same. Why? Because the pipe is uniform. Now the area is equals to A1 into A2, that is equal to pi by 4 d square, that is equals to 0.07. Then the velocity V is equals to V1 is equals to V2, that is equals to 3.5 meters per second. 3.5 meters per second. And what is the theta given in the question? The theta is 45 degrees. Now, what is the discharge? Q is equal to discharge. So we have to find out the discharge. Q is equals to A into V. Therefore, applying these values, you are getting Q is equals to 0.2475 meter cube per second. Now, the pressure head is equals to 20 meters of water. The pressure head formula is equals to rho by P by rho G, that is equal to 20 meters of water. Therefore, P is equals to 20 into rho G. Therefore, P is equals to rho 20 into rho G. Then rho is equal to 1000, G is equal to 9.81. That is equal to P is equals to 196, 200 Newton per meter square. So pressure intensity వచ్చిన తర్వాత సో మనకి పైప్ డయామీటర్ సేమ్ ఉంది కాబట్టి P is equals to P1 is equals to P2 is equals to 196, 200 Newton per meter square. Okay. Next. V1x is equals to 3.5 meter square meter per second. V2x is equals to V2 cos 45 degrees. V1y is equals to 0. V2y is equals to V2 sin 45 degrees value. Therefore, P1A1 into x, that is equal to P1A1 is equals to values kattandi, right? P1AY which is 0. Next, P2AX is equals to minus P2A2 cos 45 degrees. P2A2 is equals to minus P2A2 sin 45. So, ఇప్పుడు forces acting along the x direction, f of x is equal to, write the same formula, rho into discharge into V1x minus V2x plus P1A1 x plus P2A2 x. Now substituting those values, ఈ పైన మీరు చేసిన values ని substitute here 1000 into 0.24 into V of V P1A1, alright, V1x 3.5 minus 3.5 into 0.707 plus 196 into 200 into 0.707 minus P2A2 into cos 45. So we are getting the Px value. We are getting the Px value is 4316.98 Newton. After substituting clearly, neatly, detailedly, you are getting this one. Now the y-axis తీసుకోండి. Y-axis కూడా same. Only y's అనేది change అవుతుంది. Now 1000 into 0.24 into 0 minus 3.5 into 0.7071 plus 0. The same thing, apply just applying those values. I'm substituting, we are getting minus 10,420.44 Newton. The negative sign indicates is in the downward direction. So manaki, as per the question, the figure is drawn. It is 45 degrees. Now the pressure is acting same. Pressure ki idi veskondi, velocity ki ee figure vesesandi. Now what is the resultant force? The resultant force Fr is equal to root of f of fx square plus f of y square. So substituting those values, you are getting the value 11,279 Newton. Once you got the Fr value, you have to go for the tan theta. Tan theta is equals to f of y by f of x. Substitute those values, you are getting tan theta 2.411. Therefore, theta is equal to tan inverse of 2.411. That is equal to 67.28. 67.28 minutes. So like this, you can solve a number of problems whenever you are getting the problems in the exam. Okay, I think this is the last problem. Yes, in a 45 degrees in a 45 degrees bend of a rectangular air duct of 1 meter cross section is gradually reduced to 0.5. అంటే 1 మీటర్ ఉన్న క్రాస్ సెక్షన్ గ్రాడ్యువల్గా 0.5 మీటర్స్కి వెళ్ళిపోయింది, అంటే ఏరియా తగ్గిపోయింది. ఫైండ్ ద magnitude of the force required to hold the duct in the position if the velocity of flow at the 1 meter section is 10 meters per second and the pressure is 2.9. Take density of air is 1.1116 kg per meter cube. So direct question, what is the given data section? So మనకి పైప్ అనేది తగ్గిపోయింది, సో పైప్ ఈస్ గ్రాడ్యువల్లీ రెడ్యూస్డ్. సో మనకి ఇక్కడ 1 ఉంది, ఇక్కడికి వచ్చేసరికి 0.5కి వచ్చింది. నా వాట్ ఇస్ సెక్షన్ 1 వేసుకుందాం, సెక్షన్ 2 వేసుకుందాం. సో సీ ద ఫిగర్ హియర్. సో ఇక్కడ మనకి 1 ఉంది, ఇక్కడికి వచ్చేసరికి టేపర్డ్గా అయిపోయి 0.5కి వచ్చేసింది. సో V1 P1 A1, V2 P2 A2, సెక్షన్ 1 సెక్షన్ 2, ద యాంగిల్ ఇస్ 45 degrees. సేమ్ వెలాసిటీకి ప్రెజర్కి మీరు రైట్ ద draw the figure like this. Next, at section 1 area is equals to 1 meter square, section 2 is 0.5 meter square, P1 is equals to 10 meter square, P1 is equals to inta అని ఇచ్చాడు. Density of area and rho is equals to 1.1. This is given data. Apply the continuity equation. So మనకి ఏం కావాలి ఇక్కడ, we don't have the velocities, V2 కావాలి. సో డిఫరెంట్ డయామీటర్స్ ఉన్నాయి కాబట్టి ఏరియా సపరేట్, వెలాసిటీ సపరేట్, డయామీటర్ కూడా సపరేట్, ప్రెజర్స్ కూడా సపరేట్. నా అప్పుడు ఈ ఫార్ములా అనేది యూజ్ చేసుకోవాలి. కంటిన్యూటీ ఈక్వేషన్ A1 E1 is equals to A2 V2. Therefore V2 is equals to A1 V1 by A2, that is equals to 20 meters square. That is the value you got from the continuity equation. So the discharge Q is equals to A into V1, A1 V1 or A2 V2, ఏదో ఒకటి తీసుకున్నా కూడా you are getting the discharge is equals to 10 meter cube per second. Now applying the Bernoulli's equation at section 1 and 2. So normally apply the Bernoulli's equation at section 1 and 2. We are getting rho 1 by rho g, P1 by rho g plus V, pressure energy plus kinetic energy is equals to datum line లేదు కాబట్టి pressure energy plus kinetic energy is equals to pressure energy plus kinetic energy at section 2. Now apply this pressure 1, 2.943 into 10 power of 4 divided by rho into rho ఇక్కడ మనకు 1000 తీసుకోకూడదు. Why? The question has given the density of air is 1.16. So take 1.16 into 9.81 plus 10 square into 10 square divided by 2 into 9.81. So after simplifying and substituting all these values, మనం P2 కనుక్కోవడానికి we are using Bernoulli's equation. So initially గా ముందు వచ్చిన ప్రాబ్లమ్స్ లో మనకి pressure 1, pressure 2, diameter of pipe same కాబట్టి we have not used Bernoulli's equation or continuity equation. So మనకి whenever the diameter of pipe same ఉంటే సో డైరెక్ట్గా మనకి f of x, f of y and resultant force r కనుక్కోవచ్చు. Whenever you are having changes in the diameter, అప్పుడు మనకి continuity equation, Bernoulli's equation మనకి కన్సిడర్ చేసుకోవాలి. Now so we got the values by using the Bernoulli's equation, P2 value. Now సేమ్ మళ్ళీ ఇక్కడి నుంచి మళ్ళీ మామూలుగానే for x-axis f of x is equals to, write this formula, at a1 x 10 meters v2 is equal to v2 cos 45, that p1 a1 p2 a2 at x. So after getting all these values, substitute f of x is equals to 1.16 into discharge, substitute values, all these values, finally you are getting f of x is equals to this one. Okay, next f of y. F of y applying the same formula, just y అనేది changes చేయండి. We are getting v1 y 0, v2 y is equals to v2 sin 45, that is equals to 20 into 0.701, that is equals to 14.142. Therefore substitute p1 a1 into y, p2 a2 into y. So f of y లో substitute చేస్తే you are getting this value. So finally resultant force కట్టండి. Fr is equals to root of fxy plus fy square, that is equals to 2.21746.6. Okay, now the direction of for the axis theta is equals to f of y by f of x, that is equals to 0.5519. Substituting theta tan it వచ్చినప్పుడు theta value tan inverse of 55 Okay, tan theta is equal to tan inverse of 0.5519, that is equals to 20 degrees 53 minutes. So like this you have to solve the problems for the pipe bend equation, pipe bend problems. Now the next topic and last topic in the unit 2 is the types of motion. The types of motion. A fluid particle while moving may undergo any more. The fluid particles while undergoing, it may go in any direction or a combination of directions or combination of displacements, right? A fluid particles while moving may undergo any one or combination of following four types of displacement. So what are the four types of displacement? First one is linear, second one is linear displacement, third one is angular deformation, fourth one is a rotational. The first one is linear translation or pure translation, next one is linear deformation, third one is angular deformation, fourth one is rotation. Okay, then what is the first thing you will see? A linear translation. It is defined as the movement of a fluid element in such a way that it moves bodily from one position to other position, and the two axes A, B and C, D represented in a new positions A dash, B dash and C dash, C dash parallel to the object. Now see the x-axis and y-axis. X-axis and y-axis. Now based upon the x-axis and y-axis, draw a component, maybe A, B, C, D, right? A, B, C, D. So in the linear translation law, so purely it is moving in x direction or y direction. So whenever it is moving in x direction or y direction, obviously what happens? This is moving from here to here. Pure translation జరిగినప్పుడు only displacement is moved, area is not affected. So what happens here? ఈ పాత ఏ ఉన్నది ఏ డాష్కి వచ్చింది కొత్త పాయింట్కి, డి ఉన్నది డి డాష్కి వచ్చింది, బి ఉన్నది బి డాష్కి వచ్చింది, సి ఉన్నది సి డాష్కి వచ్చింది, రైట్? So this is a changing in the linearity. X-axis lo, y-axis lo it has been moved, but there is no changes in the area or volume. Next, what is the second one? Linear deformation. It is defined as the deformation of a fluid element in linear direction when the element moves. The axis of the element in the deformed position and undeformed position are parallel, but their lengths change. So, linear deformation lo em జరిగిందంటే, so whenever you transformed normal ABCD ఉన్నది మీరు transform చేసినప్పుడు linear గా, what happens? It has took some changes in the lengthwise. See here, the so whenever it has been moved, the undeformed position are parallel, but length ఏమైంది? లెంత్ ఏ నుంచి బి దగ్గర ఉన్నది సాగిపోయి బాగా సాగిపోయి ఆర్ గెటింగ్ ఏ డాష్ అండ్ బి డాష్, అండ్ ఆల్సో స్క్యూ జరిగినప్పుడు సి డాష్ అండ్ డి డాష్. దర్ ఇస్ అ చేంజ్ ఇన్ ద లీనియర్. నెక్స్ట్ third one is angular displacement. So whenever you are getting angular displacement, what happens? Angle change అవుతుంది. So initial గా మనకి ABCD ఉన్నప్పుడు whenever it is making an angle, rotating to an angle, so the x-axis ఉన్న base datum line ని making some other line, that is dou y by dou x, right? Dou y by dou x, dou y by dou y. Now it is making some angle, that is theta. ఇక్కడ కూడా మనకి యాంగిల్ theta. So delta theta 1 is equals to dy by dx into change in the direction delta x. Delta t2 is equals to du by dy into delta y, change in the y direction. Okay na? This is nothing but angular displacement. So the angular displacement or shear displacement is defined as the average change in the angle, the average change in the angle with adjacent sides, the theta 1 delta theta 1 delta theta 2, or the change in the angle between the two adjacent sides of the liquid element, fluid element. This then angular deformation can be written as half delta 1 theta 1 minus delta theta 1 plus delta theta 2. Now the delta theta 1 is equals to dou v by dou x into dou x by dou x, that is equals to dou v by dou x and dou theta 2. Now there is a things you have brought. Now what is the angular deformation? Half of delta theta 1 plus delta theta 2. or the shear strain changing half dou v by dou x plus dou u by dou y. Next, fourth one is the rotation moment with rotation motion. So see the rotation motion here, A, B, C, D. It is changing the orientation, thereby the change in the length is also disturbed. Then how it is defined? It is defined as a movement of a fluid. It is defined as a movement of a fluid element in such a way that both of its axes, horizontal axis as well as vertical axis, rotate in the same direction, which is equal to half dou v by dou x minus dou u by dou y for two-dimensional element in the xy plane, right? So here what happens here, whenever you are getting a change in the motion, so A, B, C, D is moving with respect to the same axis, therefore there is no change, during the rotation in the direction. Okay, now, so therefore with the rotational moment for a z-axis 1 by 2 dou v by dou x minus dou u by dou y xy. For a x-axis 1 by 2 dou v by dou y minus dou y by dou z yz. For y-axis, this is for x-axis, this is for y-axis, half dou u by dou z minus dou w by dou x, that is for y-axis. So with this we are having three types of motion in the problems. Then what is the vorticity? It is defined as a value twice the rotation, and hence it is given as 2w, that is angular rotation, vorticity. Now with based on these small things, we are having some problems related to the types of motion. A fluid flow is given by v is equals to 8x cube I minus 10x square yj. Find the shear strain rate. State whether the flow is rotational or irrotational. So v is equals to 8x cube I minus 10x square yj అన్నప్పుడు what is the u you are taking? The u is 8x cube. Okay, u of I కాబట్టి u is equals to 8x cube. దాన్ని మీరు డిఫరెన్షియేట్ చేస్తే 8 3 24 x 3 కాబట్టి 2 వస్తుంది d square dou u by dou x. y చేస్తే that is 0 వస్తుంది. Now v is equal to minus 10x square కాబట్టి differentiate with x, we are getting minus 20 xy. y differentiate చేసినప్పుడు we are getting minus 10x square. What the shear strain rate is given by the equation half. సో ఇక్కడ మీరు తీసుకున్న ఈక్వేషన్ పైన తీసుకున్న ఈక్వేషన్స్ లో half dou v, ఇది shear strain dou v by dou x plus dou v by dou y is equals to half. X and the x is equals to minus 20 xy plus 0, that is equal to minus 10 xy. Next, rotation about the y plane. Rotation about the y plane with the equation is equals to wz with respect to rotation. There is a formula. So after substituting these values, minus 20xy minus 0, that is equal to minus 10xy. Right? Next, other problem. So the velocity of components in two-dimensional flow are u is equals to this one and v is equals to this one. So show that these components represent a possible case in a irrotational flow. So what is the given data? U is equals to, this is a value. So మీరు u తీసుకొని దాన్ని సబ్స్టిట్యూట్ చేస్తే x తో we are getting ఇది 0, ఇది 2, ఇది minus 2x y. Differentiation y తో చేస్తే is a value. So then what is v? v తీసుకొని dv dou v by dou y తో చేస్తే ఇది, x తో చేస్తే ఇది. Now for two-dimensional flow continuity equation, this is a formula dou u by dou x plus dou v by dou y is equal to 0. Substituting these values, we get this is a thing. So which is possible for the fluid flow case. Then for rotation wz, so మనకి ఇక్కడ xy తీసుకున్నాం కాబట్టి rotation with respect to z is given by wz is equal to half dou v by dou x minus dou v by dou y, that is equals to half y square minus x square to the bracket minus y square minus x square is equal to 0. Therefore the rotation is 0, which means that in case of irrotational flow, which means it is a case of irrotational flow, the rotation is equal to 0. So like this we have to solve the problem for the types of motion with respect to the two-dimensional flow. Hope you understood, right? So with this, the total unit 2 is successfully completed. So we'll switch on to the unit 3 class in the next session. So thanks for listening the class patiently. If you have any doubts, just you can chat me or you can talk to me, right? So these are the problems related to the pipe bends and also the types of motion, right? Yeah, thanks for listening patiently. Once the video is uploaded in the YouTube, I will forward this link to the WhatsApp group. Open it, share it, and view it, and also share the link to the students, those who are not in the class also, right? Yes.